Hey there. We are going to talk about eccentricity right now. And this is something that might be on your lab practical. And if you remember, eccentricity involves some cardboard. And actually, for your um, lab practical, you get like this piece of fat looking stuff. It's a dissecting mat, it's a blue dissecting mat. So we'll just use cardboard for now, like we did in the lab. We've got our pins. And you're not going to have to figure out where to put your pins. If you follow the directions, it tells you pretty clearly where to put them. So you put them into your piece of paper where you're supposed to. So I drew a line and made two points. And I take my string and I put it over. And again, just follow your directions on the lab practical. Take my pencil and I draw a nice ellipse. So I take extra care to make sure that I did a good job getting the major axis done. So now what do? Take the pins out, and I'm going to keep following my lab practical directions, but it's going to tell me to figure out the eccentricity. So eccentricity is right there, distance between the foci divided by the length of the major axis. So what does that mean? The distance between the foci, or each focus point, is this distance here, and the length of the major axis is this whole thing here. So we measure those, and we always use centimeters for that. So the distance between my points here, do this to the nearest tenth, and man, mine comes out to right about 4. So I'm not going to write 4 down, I'm going to write 4.0 centimeters. That's the distance between my foci, and then the length of the major axis, I put 0 at one end, and this one comes out to about 15.6 centimeters. So now, like always, you put the top number into the calculator first, and you see what you get. So here is a fancy calculator. We're going to put in the top number first. There I am. 4 divided by 15.6 equals, I get this big number. They want you to write it down to the nearest thousandths. So it's going to be 0.25. Remember, this should always be between 0 and 1. The closer it is to 0, the more circular it is. The closer it is to 1, the more squished it is. So does that 6 stay a 6 or go up to a 7? It stays a 6 because the 4 is less than 5. So 0.256, and we don't put any units on because my centimeters cancel out. So that'd be my eccentricity of this ellipse that I drew. So now they're going to give you a table and ask you to compare the eccentricity of your ellipse to a planet. So to use this as an example, and the one that they have in the Regents is a little bit more cut and dry. It just has the planet and the eccentricity, but we've got the planet and the eccentricity right here, these two columns, and that is going to allow you to compare that. So let's say they asked me to compare my planet with Mars, and we write down Mars's eccentricity is 0.093. So Mars equals 0.093. And then it's going to ask you which one is more elliptical. And to figure that out, you just look at which one is more squished, and you have to choose. My ellipse is more elliptical, less elliptical, or the same as Mars. So this one that we drew is more squished than Mars. Mars goes around in more of a perfect circle than this. And that's about it. The station's pretty easy. Goodbye.